What's up, everyone? This is LeetCode 981, time-based key value store. We've done this problem in Python. We're going to do it in C++ now, right? So we have to design a time-based key value data structure that can store multiple values for the same key at different timestamps and retrieve the key's value at a certain timestamp, right? Make sure you look at the example. It'll help. But basically, we have to, you can almost think of it like we have to implement a hash map basically with a key, right? And for the value in the hash map, we have an actual string that's a value and a timestamp, and those are basically a pair, right? So it'll look something like this, okay? So we add, so this is our key, right? And then we could add something like this, right? What this is, the string value is bar, the timestamp is 1. Then we can add something else like bar2 with the timestamp 4, right? And we basically have to support setting, which should be easy enough, right? Just like a normal hash map. But the get is where it gets a tiny bit more complicated. We'll touch into that. But basically, when we get something, we have to basically, we pass in the key and the timestamp, and we have to see if that exists, if there is a key with such a timestamp, and if there is, we have to return the value. So for example, if we use the get function and we pass in this key, and let's say the value timestamp 5, well, we're going to check and we're going to say, oh, wait, there is no timestamp 5. So in cases like that, what we're going to do is we're going to take the most recent timestamp and return its value, okay? Now, likewise, let's say we're using the get function and we use this foo, and we use the timestamp 4. Well, that does exist, right? So again, we just return the value. Because keep in mind, here, we're just returning the actual value as a string, right? I mean, that's the point of the pair. But we're using the key and the timestamp to determine whether it exists, and if it does, we return the actual string value. Okay, now there is also another edge case where we have to handle where if nothing exists, and let's say we check foo with timestamp 5, and there's nothing here, right? Well, in that case, we return an empty string, okay? And it'll tell you a little bit more here. That's basically what this is telling you. I just wanted to explain it in my own way because I think reading this maybe is a little bit confusing. Okay, so there is a couple edge cases we have to handle. Okay, so I'm going to write some comments out too, just so it's a little bit clear what we have to do. So here we're going to say note, right? And we're going to go down here. I'm going to copy this and paste it, right? Because there is something really awesome for us, which is that the timestamps of the set are strictly increasing. So when, time is linear, right? Right. If we add something to the hash map, it's at a certain time. Well, next time we add something, that timestamp is going to be greater. So you won't ever add something at timestamp like 2, and then later on we'll add something and the timestamp will be 1. That we're not going to run into that problem, and this makes this problem a lot easier, right? Because we don't have to handle that edge case. So this is very useful, and that's why you should always read your constraints. Always useful, right? So anyways, let's move forward. So we're going to create our hash map, okay? So we're going to say private. I'm going to say unordered map. We're going to say string. And here we have a pair, which is just the string and the int, right? And again, this is basically a key which maps to list of values and timestamp. Okay. Now set. Now this is where we have to do something. So we're given the key, the value, and the timestamp. We have to insert it into our time-based key value data structure, right? So if the key doesn't exist, we have to create the key. And then after that, regardless of whether the key exists or not, because if it doesn't, we create it, right? After that, we're going to basically take the value and take the timestamps and put it into our hash map, okay? Because again, if the key doesn't exist, we'll create it first anyways. And if it already does exist, we're not going to enter this if statement that we're going to write. So we're going to say if hmap dot find key, right? We're going to say equals hmap dot end, right? And we're going to, so if it doesn't exist, what we're going to say is we're going to create this key. So we're going to say hmap key, and we're going to say vector pair string int. We're just going to pass it empty, okay? Because down here is where we'll actually populate it. So we're going to say hmap key dot push back. Or we're going to say, we're going to give it the value and the timestamp, okay? So again, we're just creating our key if it doesn't exist. And then afterwards, regardless of whether it exists or not, because again, if it doesn't exist, we're creating the key. Then we're going to push the value and the timestamp. So yeah, make sure you refer to this image in your mind. It'll make it more helpful to think about how we're doing this. Okay, so now here, right? And let me actually, I said I was going to write some comments, right? Let me make sure I write this. So we're going to say, we're going to set the key for the values, set the value and timestamp together. Gets added to the end of the list, so it's O of 1, right? So here is the get function. And now this is where it gets a little bit more complicated, right? Because there are a few edge cases we have to handle. So we're going to say, we have to say, keep in mind, we have a pair, right? So we have a pair, but we are returning only the value, right? Meaning our input is, we have a pair, right? The timestamp, the value and the timestamp for our, right? This is a value and string value, and this is a timestamp, but we're only returning this. That's what I'm saying. Like, we're only returning this. And our input is this and this, but our return is only this, okay? So just keep that in mind. So we have to write some other stuff. So basically, if we don't have a match, return the most recent value given the key. Or return the empty string if there is nothing. Okay? So why binary search, right? We're gonna have to use a binary search, right? And it's very simple, right? Linear scan, O of n, worst case, right? Binary search is O log n, right? So we're actually gonna have to use a binary search. Now, let's discuss that really briefly, right? In the worst case scenario, if we're looking for something, like, because this can get really big, right? Like, let's look. Timestamp 10 to the power of 7. Not that. This length. I guess it can go up to 100. It's not too bad, but still, we can make it more efficient, right, by not using a linear scan. Because if this was really big, like in an interview, this length could be really big, right? You don't want to do a linear scan when you don't have to. Because why would we want to, like, let's say we're looking for a value, I don't know. Let's say we're looking for a 3, right? Well, do you really want to start from the start and go all the way like this, right? Or what if we're looking for 100 or something, right? Why would we want to do that when we can, because a linear scan is O of n. Well, if you use a binary search, though, because we're basically looking in the midpoint every time and deciding whether we care about the left side or the right side more, given some conditions for binary search, the time complexity is O log n rather than O of n, and it's more efficient. So that's why we're going to have to use binary search, right? We're reducing complexity when we can, right? And maybe in an interview they wouldn't care, I don't know, but if your interviewer actually does care about this stuff, like, you have to use a binary search, it's more efficient. Okay, so that's what we're going to do. So we're going to say, first of all, we're going to create a string called answer, and this is what we're going to return, right? It's going to basically, this is going to get updated or not depending on whether we found a value or not. Okay, and we're going to say vector pair string. I'm going to say and values map key, right? So this right here is basically we're basically doing if no key is found, return the empty list, right? Right. We're just returning an empty list if we can't find any key. Okay. So now we have to do the binary search, right? And this is a little bit tricky, but we can do it. So so the reason we have to do this, by the way, is, like, we can have multiple values, right? That's kind of the issue. So we don't know. So we want to basically take the length of this to do our binary search, right? That's basically what our right pointer is, okay? So that's why we're going to do values.size here, -1. Okay, pretty neat. Okay, so that's what the point of this is. And again, we have to do L minus or less than or equal to R, just like a regular binary search that we know and love. And this is where we do the midpoint stuff, right? So we're going to say int m is equal to L plus R divided by 2. You can do the L, I forget how it is. Let me check really quick. I always forget because I'm not the best plus person, right? So instead of doing this, what we're actually going to do is we're going to say L plus, and then we're going to say R minus L. Okay. Now, just to keep in mind, the reason we're doing this is because we could have a really big input, right? And we don't want any overflow. Now, granted, our lengths are pretty small, so it's not really an issue. Like it's not really an issue, but in a very complex problem, we could have overflow, so we actually want to do it like this, and it's just a good habit, right? So we're just gonna do it like that. So okay, here, right? What we are, and this is basically where we shift the pointers around. And so I'm gonna write some comments here just so we are clear on what we do, right? So we want to see if we have a match. Whoops, I need to make sure I comment. We want to see if we have a match still. So we move the pointer. We move the pointer to the right. However, this value is still valid and could be most recent value. So we update the answer first, right? And we're going to say if values m dot second less than or equal times stamp, we're going to say answer is equal to values of m dot first L L I don't usually cuss, my bad. L is equal to m plus 1. We're gonna say R is equal to m minus 1. So I'm gonna explain this, right? I just had to write that out first. So what we're doing here is, like, let's say we're looking for a timestamp 5, right? Well, let's say we go to the midpoint and we're here, right? Well, we know that 5, this is less than or equal to 5, but it could be less than, right? So it's possible this is not equal to 5 and 5 does exist. So what we're going to do is we're going to take this here, right? This here. Let me use a different color, actually. Let me take this here, and we're going to put it into answer, and then we're going to shift the left pointer over here, right? And we're going to do binary search again to see if we can find the 5. Now, if we don't find the 5, it really doesn't matter because we already stored this in answer, right? So we'll use that to basically return the most recent value, okay? And let's say 5 does exist. Well, then the answer variable is actually going to be updated, and it'll point here, right? And it'll be this. Well, it won't be this. It'll be the actual value, not the timestamp. But yeah, that's basically our binary searches working and how we're handling like the different edge cases. Now, if that's not the, and obviously also, let's say we go here and our timestamp should actually be somewhere over here. We have to move the right pointer over. Okay. And that's basically what we're doing. Like, we're just handling the edge cases like that. And this line is super important. Make sure you understand what it does, like I just explained, right? It's to basically keep track of the most recent, or it'll actually update and keep track of the actual value for the given timestamp in our input up here, if it does exist. So those two edge cases get handled here. Now, if something doesn't exist, like if a key and a value don't exist, right? We have this is going to be 0, right? So we're going to say 0. And R is going to be 0 also. Like, meaning, what I mean is, like, if there's nothing here, right, the length is going to be 0, right, because it doesn't exist. And thus, L is going to be equal to R, so we actually, we wouldn't really do anything, right? Because we would do 0 minus 1, actually, sorry. So it'd be -1, so it'd be, is 0 less than or equal to -1? No, it's not. So we wouldn't even enter this, and we just return answer, which would be the empty string, which is what we expect, right? Because, again, remember, if we have nothing here, and we want to look, okay, we pass in the timestamp 5 and this key, wait, there's nothing here. Well, in that case, we just return the empty string, right? That's all we're doing, okay? Just make sure you read this. Those are basically the 3 edge cases you have to handle. Like, just think of it like that, okay? Either the timestamp does exist and we return the value, the timestamp doesn't exist and we just return the most recent value, or nothing exists and we just return the empty string, right? I'll just break it down like that, okay? So yeah, just make sure you understand what's happening here. And I don't really think this implementation is that hard. I think it's just a little bit tricky to think through. This problem is a little bit tricky, but like the implementation, not too bad. But yeah, I hope this helped, and I'll see you next one. Peace out.